Okay, so lesson 91, number 13, we have an exponential expression, and we're going to try to simplify that. Now remember, an exponential or a power is just a base, like x, raised to a power, like a. X is the big number, a is the little number that's raised up. And what that means is this is telling you to multiply x by itself a times. For example, x to the third means x times x times x. That's what it means. All right. There are certain rules and properties of exponents, and we can use those to simplify this expression. So one rule is that if you have a power, like x to the a, raised to another power, like b, you can multiply those exponents, x to the a times b, and it makes total sense that that's true, because if you had x squared raised to the third power, that just means x squared, x squared, x squared, which is xx, 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 which is x to the sixth, which is 2 times 3. So that rule makes sense. All these rules make sense. All right, the next rule is x to the a times x to the b is equal to x to the a plus b. And we would say that means if you have like bases, meaning the bases are the same, the x's, and you're multiplying those, you can add the exponents. And that also makes sense, because if you have x squared times x cubed, that is equal to xx times xxx, which is x to the fifth, and that is 2 plus 3. So you can add the exponents when you multiply like bases. When you divide like bases, you can subtract the exponents, and that makes sense too, because if you have x to the fifth over x squared, that equals x, 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 x divided by x, x, and 2 of those x's are going to cancel out, and you just end up with x cubed, which is 5 minus 2. So all those rules make complete sense. Kind of notation that's involved with exponents is that if we have 1 over x to the a power, we can rename that x to the negative a power. What you cannot do is change the sign on the base. One of the things I've been seeing people do lately is you might have something like this, and they are rewriting this as negative 2 x to the negative 4. Well, this is not an exponent, it's a number. You can't just move it up to the numerator and change its sign. That's not algebra. That's not allowed. This is not an exponent. So you cannot do that. That would be absolutely wrong. This could be written like this. But anyway, so those are the rules that go along with exponents. So we're going to start by using this first property of exponents. When you have a power raised to another power, you multiply the exponents. So you're going to have x to the b times 2 minus a, x to the ab over x to the ab over 2. Now, your next thing you could do would be to use this second rule or property of exponents, where if you multiply like bases, you add the exponents. You could, at this point, just go ahead and use this rule, moving x to the ab over 2 up to the top and making it x to the negative ab over 2. That would be another thing you could do. You could use the second and third rules at the same time. You could add the exponents on the bases in the numerator and then subtract the exponent in the denominator. So you could just jump right in and say, okay, this is x to the b times 2 minus a plus ab. So I'm adding the exponents on my like bases, and then minus ab over 2, because I can subtract the exponent on that base in the denominator. But I'm going to go through it one step at a time just to make sure there is no confusion. So I'm going to distribute that b in the exponent on x to the b times 2 minus a. So that would be b times 2 minus ab. And then I've got x to the ab, and that's all over x to the ab over 2. And now I can add the exponents on the powers in the numerator. So x to the 2b minus ab plus ab, all over x to the ab over 2. And now I'm going to go ahead and cancel those ab's, because negative ab plus positive ab is just 0. And I'm going to subtract the exponents on my like bases that are being divided. So x to the 2b minus ab over 2. And you could leave that answer like that, as far as I'm concerned, or you could get a common denominator and add those together. So if you did that, you would multiply 2b by 2 over 2, and you'd have 4b over 2 minus ab over 2, and that would just be x to the 4b minus ab over 2. But I don't think that looks any better than this does. So either one of those is perfectly fine.